Lesson 2-5, solve multi-step equations. So in this video, we're going to go through some multi-step equations using still our properties of equality to solve. So some vocabulary. We're going to review the properties of equality that we've gone through in other lessons as well. So just remember, whatever you do on one side, you must do the exact same thing on the other side. So example 1. We need to remove parentheses by using the distributive property if there's parentheses involved, and then follow the reverse order of PEMDAS to solve for the variable. So here we have parentheses involved, so I need to distribute. This would be, and technically you could actually solve without doing the distribution process. So like for this one, maybe this one I'm going to divide both sides by 2. And when I do that, I'm left with n plus 10 equals 20. Now I can get n by itself by subtracting 10, and n is going to equal 10. Now you would still get the same answer if you distribute the 2, but just know that you're going to have to divide by 2 at the end as it is. Next here, I have to distribute the 2 because I have variables on both sides. So if I distribute, that gives me 6m minus 2 equals 2m plus 2. Now I have to determine which side I want my m's on. It doesn't matter. I'm going to subtract 2m on both sides. I like getting my variables to the left or having my variables positive. And that means I'm going to be adding this 2 to both sides. So now I'm left with 4m equaling 4. To get m by itself, I get to divide by 4 on both sides. And I'm left with m equaling 1. Next here, I'm going to multiply both sides by 7. So now I have 35 plus 7x equals 28. Then I can subtract 35 on both sides. And I'm left with 7x equals a negative 7. And then I can divide by 7 on both sides. And x is going to equal a negative 1. Next here, I'm going to subtract 7 on both sides, and that gives me 5 equaling, and then I have to distribute this negative 1, which is a negative p minus 4. Then I can add 4 to both sides, and I'm left with 9 minus p, or 9 equals negative p. Then I can divide by negative 1. P is going to equal a negative 9. Now, one thing to keep in mind is here, there's really a negative 1 in front, so that's why I distribute a negative 1 because of the parentheses there. So I distribute the negative 1, and that gives me the negative p minus 4. Next here, we're going to combine like terms and then get the variables to one side. So I'm going to have my z's to the left, so I'm going to subtract 8z, and then I'm going to add 3 to both sides. Now you could do them separately. I'm just doing it all at the same time just to save some time here. So 12 minus 8 is 4, so 4z equals 16. Divide by 4. Z is going to equal 4. Next here I'm going to put my variables to the right this time. So I have negative 6n, because the opposite of adding 6n is subtracting 6n. That means I'm going to subtract 17 on both sides. And I'm left with negative 20 equals 4n. Then I divide by 4 on both sides, and n is going to equal negative 5. Now you'd still get the same answer if you put the n's to the left. I just want my n's to be positive. Next, I need to combine like terms. So this is 7v plus 9 equals 4 minus 3v. I'm going to get the v's to the left, so I'm going to add 3v to both sides. That means I'm going to subtract 9 on both sides, and that gives me 10v equals a negative 5. Divide by 10 to get v by itself. V is going to equal a negative 1/2. Next here, I'm just distributing the half. Half of 4 is 2j minus half of 6 is 3. Plus, here I need to distribute 2/3 times 3j is going to be 2j equals 1. 2j plus 2j is 4j. I want to add 3 to both sides, and that's going to give us 4. Divide by 4 on both sides. J is going to equal 1. Next, these are special cases, which means you may not have a specific answer. It could be many solutions. That means every number works, or it could be no solutions. So let's take a look at these examples. So I have 1k plus 7k is 8k plus 3 equals, on this side I have 8k, 5 minus 2 is 3. Now if you notice, both sides are the same. So if both sides are the same, this is a clear sign that this is many solutions. Because in the end, if I got all the k's to one side, I would be left with 0 equaling 0. And anytime you have a side equaling the other side, they are equal to each other. That means I can put any number in for k and it will still work out. Next, I have 2g plus 1g is 3g minus 7 equals 3g plus 1. Now, if I get the g's to one side, I have subtract 3g on both sides, I'm left with negative 7 equaling 1. Well, negative 7 never equals 1, so this would be no solution. Next, negative 3y plus 5y is 2y plus 7 equals 2y minus 11. If I subtract 2y on both sides, I'm now left with 7 equaling a negative 11. 7 doesn't equal negative 11, so this is no solution. And this last one, I have negative r minus 1 equals negative r minus 1. Since they're both the same, this would be many solutions. And a word problem. Nick drew a rectangle that is 4 times as long as it is wide. Stacy increased the dimensions of Nick's rectangle by 5 inches. If the perimeter of Stacy's rectangle is 60 inches, what are the dimensions of Nick's rectangle? So let's first do Nick's rectangle. It's 4 times as long as it is wide. So if x is the width, this would be 4x. And Stacy, she increased the dimensions of Nick's by 5 inches. So that means this would be x plus 5, and this would be 4x plus 5. We want to know what the dimensions of Nick's are, but first we have to find the dimensions of Stacy, since we know the area is, or the perimeter is 60. So that means we have 2 times 4x plus 5 plus 2 times x plus 5. Now I'm just using the formula 2L plus 2W equals P. And this is all going to equal 60. So this is 8x plus 10 plus 2x plus 10 equals 60. If I combine like terms, I'm left with 10x plus 20 equals 60. Subtract 20 on both sides. Now left with 10x equaling 40. Divided by 10. X is going to equal 4. So if x is 4, the dimensions of Nick's is 4 times 4, which is 16, and 4, which is 4. So the dimensions would be 16 inches and 4 inches. And our last one's Claire's cousin is now 3 times as old as Claire. In 10 years, her cousin will be twice as old as Claire. How old is Claire now? So if I'm going to do Claire's cousin as X. So Claire's cousin is 3 times as old as Claire. In 10 years, her cousin will be twice as old as Claire. So for that one, I'm going to say cousin's going to be X years old, and Claire's cousin's going to be twice as old as Claire plus the 10 years. So in 10 years, so now if I'm just going to use a little bit of substitution here. So I have 2C plus 10 is going to equal 3C. So now if I subtract 2C on both sides, I have 10 equaling C. So if Claire is 10 years old, Claire's cousin would be 30 years old right now. So Claire is 10 years old. Next, we have Derek drew a square and an equilateral triangle that are equal in perimeter. If a side of the equilateral triangle is 1 inch longer than the side of the square, what is the area of the square? So if we draw a square here, and let's just say this is x, 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 and x. That means the perimeter would be 4x. And this has to equal an equilateral triangle, which they would have, the side of an equilateral triangle is 1 inch longer than a side of the square. So if the side of the square is x, this would be x plus 1. So this would be 3 times x plus 1. So now if I put the equations together, it would be 4x equaling 3x plus, not 3x plus 1, 3 times, parentheses, x plus 1. So if I distribute the 3, I would have 4x equaling 3x plus 3. Subtract the 3x on both sides. We're now left with x equaling 3. And if x equaling 3, I can now find the perimeter of, or not the perimeter, I can find the area of the triangle, or of the square. So I would just have to take 3 times the 3, and that gives me 9, and it would be 9 square inches. So that is our lesson on solving multi-step equations.